All right, line V1, we're on learning test number 7, where we're going to talk about the features of control relays. And control relays are going to be a major part of almost every single one of our large and complex motor control circuits. The difference between a control relay and a contactor is simply going to be the rating of the actual contact points themselves. Oops, sorry, no, wrong one there. Inside of a relay, what we will usually find inside of a control relay is that we're going to have smaller contact points themselves that are not going to be rated to go and break the same amount of horsepower. In a lot of cases as well, we're only going to go and have single break contacts, not necessarily the double break contacts that are shown inside of here, but a lot of them are just going to be done off of a spring arm that's kind of going back and forth between one out of two positions. So the control relays will be used to go and give us auxiliary signals that we can use to trigger other devices. You know, we might use a control relay to control something of a separate value of voltage. Might be a 120 volt control circuit that I'm using, but maybe I've got a 12 volt horn. And so I would run the 12 volt through the contacts of a control relay. It's not the same as a horsepower rating, so I can carry it through there. It's just an auxiliary device, and we will see them used widely once we get into our third year motor control and into our fourth year motor control. But we're just going to introduce it in here. We're going to start by taking a look at our control relays that they give us inside of the book over here. The first thing that they show us a 4-pole relay or an 8-pole relay. These are types of control relays that are available. They are not the most common type of relay that is going to be that is going to go and be applicable. What I do want to note about these ones, though, before we talk about the other ones, is that these ones over here do have a set of normally closed contacts. Same with these ones here, normally closed contacts, and they've got a set of normally open contacts and a set of normally open contacts. This makes these things highly useful because there's going to be some things that we want to have activated, when the coil isn't pulled in, other things that we want to have activated when the coil is pulled in. In some cases, we are also going to go and see these contact points that are going to be tied together internally inside of the relay, where I don't have the option to go and untie these things. So I'm going to go and have a total of 1, 2, 3, 4, 5, 6, 7, 8. 8 components that I'm going to go and tie into. And this is probably the most common way that we are going to have it, where we're going to go and have contact points that are going to have a normally open and a normally closed on both of them. We need to talk about relay forms before we go any further, because the book doesn't identify them, but you will be required to go and identify them at some point in your future, whether now, third, fourth, or on your interprovincial. We have got 3 main forms of contact points that are going to be available to us. We've got Form A, Form B, and Form C. And A, B, and C types of contacts are just going to be different ways that we can talk about how the contact points themselves actually go and change over. Let's talk about a Form A. A Form A is what we would refer to as a normally open. Actually, I'm not going to put that right there. We're just going to put this all the way over here. Don't worry, I got a method over here for you to remember it. Like everything else, you need to have your methods for that. So a Form A is what we would refer to as an NO, or a normally open type of contact. It is normally open, we apply power, it is then going to go and close. These ones over here would be what we would refer to as a Form A type of contact. A Form B is going to be what we refer to as a NC type of contact, which is another way of saying normally closed type of contact. These would be a Form B. So where I've got a screw point and a screw point and I can attach and I've got a normally closed, we call that thing a B. This one over here would be an A. We've got a screw point and a screw point. And then the last one that we have is going to be a specialized one that is going to be an ONC, normally open and normally closed. And it's going to go and utilize what we refer to as a common inside of the, why don't I just, come on, pen, work with me. So we're going to have 3 screws off of that. We would refer to that whole setup as being a Form C relay. And a Form C relay, when that coil activates, we would see that we are going to go and have this one that is going to close and this one over here that is going to go and open. What we can do to remember these is we can just use a simple memory trick. A Form A will go and apply power. A Form B will go and break power. And a form C is going to go and change power pathways that we are going to go and have. So form A will apply a power pathway. In other words, if I've got plus, we'll stick plus 24 volts in over here. We're going to give ourselves a couple of lights. Okay, we're going to take this 24 volts. We're going to go and run the 24 volts down to this side of my control relay. Over here, like that. And then we're going to run from each of these other ones out to a light. So we're going to run to that one. We're going to run to this one. We're going to run to this one. We're going to run to this one. And then on the far side, we will go and take in our 24 volt common. Okay? Looking at this drawing that we have over here right now, you should be able to go and tell me the states of each of these lights. If we take a look at the light that is attached to the form A contact, we see that that is normally open, so therefore this light is going to be off. If we take a look at this light over here that is attached to the NO section of my form C, this whole green thing is my form C, we would see that it's normally open, so it's going to be off. But if I take a look at the other light on the form C, we would see that that thing would be on at this point. And on my form B, because we have got a normally closed path, we would see that this light would also be on. This is going to be the default or the at-rest state of this contact. As soon as we go and energize the coil, we'll just say that we energize the coil over here right now, what we will see is that my form A is going to go and apply power. Boom, it's going to apply power to that light over there because it is going to have closed. My form C is going to go and change power. It was lit there before, now it's going to be lit over there. So it's just going to go and change which of my contacts are operating. And then my form B over here is going to go and break, or it's going to go and shut off the circuit that it had because it is going to go open, right? These ones here would have been sitting open now, and these ones here would have been sitting closed. So you need to know those ones. Form A applies the power, it's a normally open. Form B breaks the power, it's going to be a normally closed, and Form C is going to be an NONC. The Form C always needs to have what we refer to as a common. Remember C, common, those things kind of go together. This is going to be a common. So both, whether I'm coming out of the normally open or the normally closed, it is always going to be the same signal that I'm going to be passing through. What we commonly have is we've got two main types of control relays. The ones that were shown in the previous page are not the most common ones that are out there. These are going to be our most common types over here. These are low quality, web snips that I have over here, but you should get the idea. This one over here is going to be an 11-pin relay. This one over here is going to go and be an 8-pin relay. And you'll note that these don't have the double break contacts. Instead, each one of these relays has got a set of contacts. You can identify those. I hope we just did this. Which one is it? Oh, that's right. It's a Form C that we have for each one of these. We can see that each of these has got a common, and a common, and that each of these is going to have a normally open, and normally open, and that each of these is going to go and have a normally closed, and normally closed over there. These are our most common of all types of control relays. Are going to be these ones that are going to be termed as being 11-pin or 8-pin. You will sometimes hear them referred to as octal base because oct is the Latin root for the word 8, because it's going to be these 8-pin ones. Anytime that I need to have 3 switching components, I'm going to have to use one of those 11-pin relays. Anytime that I need to have 2 switching components, I'm going to go and use one of those 8-pin relays. This section over here, the A1 and A2 that I'm going to have, are going to be referred to as the coil. Same as any other contactor, we apply power to that coil, and all of our Form Cs that are inside of here are going to go and change state inside of here. Technically speaking, these ones should be referred to as an 8-pin Form C. We just, in the trade, because they're so common, it's a ubiquitous thing, we just refer to that as an 8-pin relay in most cases. Okay, let's talk about the contacts that are going to be inside of these. Relay contacts can be the double break that we are going to have. Now, once again, these are control relays, so we're not looking for as strong of a set of contacts that we would have inside of these. They're going to be much, much more lightly rated. In fact, if you go and take a look at the ratings, and over here they give us a NEMA table of ratings over here, you'll note that everything inside of here is done off of VA and amps. That is not done off of horsepower ratings inside of here. They just are simply not built to go and handle actual horsepower. It is designed to go and just switch currents that could be resistive, they could be inductive. We'll use them for, other inductive components. We could sometimes use our control relays to switch the coils of large contactors. We will other times use them to switch resistive loads like lights, or even capacitive loads like LED lights that we would have. So it's a small current rating that they're going to have. Each one as well is also going to go and have different VAs that they're going to be able to go and make. So they can close in on 60 amps. They can break only 6 amps, and they can only carry 10 amps at 120 volts for this specific one that they have over here for this auxiliary contact. It can go and close in and have an inrush. It can interrupt a low amount of current, and it can continuously carry a medium kind of amount of current that we would have off of these ones. The relay coils are usually going to go and be sealed, like hermetically sealed types of units. Sometimes we will have epoxy encasement. Other times they are going to be placed inside of these clear little cubes. We tend to refer to those ones as an ice cube relay. You will hear that term because it looks kind of like a little square ice cube. It's a little clear plastic thing like this, and it's going to go and plug onto a much larger base that's going to be part of that, and the base is where all the screw terminals themselves are going to go and be. These type of control relays, the bases themselves are going to be DIN rail mounted. That's going to be that special type of mounting track. If I look at a side profile, it looks like this. We place inside a control cabinets, and we can snap our bases onto these. There, I'll give you a 3D view of the DIN rail. So that's my DIN rail itself. That's what we would go and snap these things onto. The actual relay coil itself can get plugged onto here. So this whole thing, this ice cube itself, plugs in and out. We're going to use usually bayonet types of lugs. If you have got different values of voltages, we're usually going to use the same base plate, because the base plate is simply just going to be screw terminals with a little chunk of copper going through the inside to these, and then we just put on the proper voltage rating of our control relays themselves. They do have a fairly high voltage tolerance, meaning that they are going to go and pull in or operate at a relatively low voltage. They go all the way down to about 85-ish% that they're going to go and have. And they're also going to go and wait to drop out until about 85%, which is good, because we're oftentimes going to be dealing with systems. When we're dealing with this, it's a motor system that will have a lot of inrush current. And because we get a lot of inrush current to the motor, and all of it's going through the contactor, we're going to get a lot of voltage drop during that inrush section. You've probably seen that before, where you turn something on, like the whole system kind of browns out for a second. That's the inrush that's causing that to happen. Obviously, if whatever's turning it on is going to be this relay, we wouldn't want this relay to just drop out because it's being browned out for a couple seconds. Then we get erratic operation. And so as a result of that, they just have to have a higher voltage tolerance. The one problem with control relays is that they do need to be energized at all times to maintain their state. So whatever I've got for my coil inside here, if I wanted to switch this over like that, both of these would switch at the same time, I would need to maintain energization on my terminals 2 and 7 over here. It's standardized terminals, by the way, on these. If I maintain that, I do have Watt's loss. And some of these control circuits, particularly in large-scale control cabinets, can be very large. So be careful with that. If you feel like, that's going to be too much power that's taken off of them, you can go with a more expensive type of control relay, which is going to be a latching type. It's a low-quality rendition that they have over here. This is going to be a side view as well on this one. You'll note that it's got the same sort of contacts, right? We're going to be able to carry our current through here and back out again once this thing closes in. And it's going to go and have a little lever inside of it. So we've got what is referred to as the latch coil and the unlatched coil. Basically, whenever this coil that's in here, the latch coil, energizes, it is going to create a magnetic field. That magnetic field, those elastic bands grab this and they pull it back up. Boom. And so it's going to go and cam that in. This thing twists off of there. When that thing twists, that's going to push this end out while this end pushes in like that. And that end pushing out is going to go and close those contacts. At the same time as it's pulling up, this little section down here, the latch mechanism, is going to go and pull straight. It actually pulls a little bit beyond straight. I want you to think about it kind of like locking your knee. This here would be like normal knee, but you know how like when you stand really straight, you can kind of like lock your knees backwards and stuff. That's basically what happens. So at that point, we can unpower our latch coil over here, and it's going to stay locked in because its knees, so to speak, are locked up over here. When we want to go and unlock it, all we do is we provide power to a little unlatched coil. The little unlatched coil rejects a plunger out of it. It's what it's going to go and do. And basically, that little plunger getting pushed out, so here it is in the latch state, is like somebody kicking you in the back of your locked knees, right? Your knees are going to unlock, you're going to be able to, kind of sink down. So that's the way that we go and hit these things for latch and unlatch. They're great if we've got long-term operation. If we've got something where we're going to turn that thing on at the beginning of an 8-hour shift, and we're not going to shut it off till the end of that shift, they're great for that. Or if we've got something like lighting. Lighting is a great thing to go and put through these ones, because at the beginning of the day, you click that thing on and it's going to go and stay on. You don't hear this continuous like of those contactors inside of the electrical room. It's just going to go and kick that thing on. It stays like that, and then we kick it in the back of the knees to unlatch it later on that evening. All right, that is it for this one over here for Learning Task 7. We are going to go and get into the jogging circuits tomorrow. Or maybe later on today. I don't know. We'll figure that out. But that's the next thing we're going to look at.